In this video, I want to show you a strategy where instead of graphing this, we're going to find the domain mathematically. I've written down my strategy below into a few steps. The very first thing I like to do is I look at the numerator of the original problem, and I want to know what values of x aren't allowed. Now, similarly, I'm going to repeat that exercise for the denominator. And then this last step here is optional because you don't have to do it. But because it's sometimes helpful to visualize the domain, I'll put this on a line graph because I want to know, okay, well, if there are pockets in the domain, I want to make sure that I don't miss those in my final answer. So let's make an assumption before we go on. For the problem that you see here, y equals the square root of x minus 4 over x, we're only going to work with real numbers in this exercise. It's a whole other video discussion if we're going to allow complex numbers. So with that being said, before we actually get started, if you haven't already, hit that like and subscribe button if you like what you see here, and turn on that bell notification so you don't miss my future videos. Now, for the numerator, notice that if we're talking about the set of real numbers, this means that we're not allowed to have values of x where you're taking the square root of a negative. So as you can look at this example exercise here, we want to make sure that x minus 4 is not negative. And what this means is that if we write it as x minus 4 is less than 0, which will give you all values that are not allowed for x, that means that if you add 4 to both sides, you will get x is less than 4. And try it for yourself. Take a value of x that's less than 4, say 2, negative 5, it doesn't matter. If you were to plug it in for x here, notice that you'll be taking the square root of a negative, and that's not allowed. Okay, so for the denominator, when we want to find out what's not allowed here, you don't have a square root, but notice that you're not allowed to divide by 0. So the restriction we have in the domain is that x cannot be 0 in the denominator. So this step is optional, not required, but I like to then combine what I learned about the numerator and denominator here and place it on this little number graph. Now, it's not a Cartesian XY graph, but it's still something visual and quicker to help us find the solution here. Now, in the bluish green color, I marked it as the number 1. That's going to be what I found from the numerator. Remember, x is less than 4 gives you all values of x that are not allowed. So I marked them out. So notice to the left of the number 4 here, anything in that shaded region or lined region is not going to be allowed in our answer. Now, similarly, for the denominator, I put a little x here under the number 0, and I gave it a label of 2 because that was step 2, right? 0 is not going to be allowed in our answer as well. Can you notice that 0 is actually basically already covered by step 1 because it's already in that shaded region, right? So with this being said, what do you think the domain is? If you haven't yet left that comment below, now you have enough information to hopefully come up with the answer. So let's hear it. Okay, you should notice then that any area that's not shaded or marked with an X is going to be part of the answer. So in other words, 4 and 5 are going to be part of the answer. And if I were to extend this out infinitely to the right, anything greater than or equal to 4 is going to be your answer. Now, this is a shorthand answer for the domain. If you're in some other classes, like for instance, discrete mathematics or, some upper division stuff, they might want a more formal answer for the domain. So you could say D is a domain function, and we can rewrite it with this notation below. And there are 2 options here, and it depends on what your teacher wants, right? So if I were to look at the top one, I would read this as the set of x such that x is real, because remember, we're in the set of real numbers, and the comma is basically like an and here. X is greater than or equal to 4. Now, depending on the class, instead of saying x is real, you might want to use this element notation to say x is an element of R, the set of real numbers. So there you have it. I hope this video was helpful for you. And if you haven't already, be sure to check out this other playlist for more AP Calculus prep, and I'll catch you later.